Number 18, an investment of 75,000 increases. So that's our initial amount. It's going to increase at a rate of, we're going to move the decimal over 2 places, and it's per year, so the compounding is 1. It doesn't affect it if you divide by 1 or multiply by 1, so I won't even put it in there, 0.125. And after 30 years, we'll put in 30, and we'll see what happens with this. So 75,000, if you don't touch it for 30 years and it increases at a 12.5% rate, which is a really good rate, that's how much money that you will have. So 2568247.87. Kelly plans to put her graduation money into an account, leave it there for 4 years while she goes to college. She receives $750, that's her initial amount, puts into an account that earns that much in compounded semi-annually, that means twice. And so we're going to have 1 plus 0.0425 divided by the 2 raised to the 2 times 4. So we'll put that in the calculator, 750, 1 plus 0.0425 divided by 2 raised to the 2 times 4, which is 8, and gets the 887.40. Number 20, wants to have a total of 4,000 in 2 years so he can put a hot tub on his deck. He finds his account compounded monthly, that means 12. How much should he put in? So we don't know the initial on this one. We want 4,000 in the end. We don't know the initial. 1 plus, we got 5%, so 0.05 divided by 12 raised to the 12 times 2. And so we're going to start off by putting this in the calculator, and then we'll divide 4,000 by whatever that box is. And so we'll put in the box first. And so 1 plus 0.05 divided by 12 raised to the 12 times 2, which is 24. And then we're going to divide the 4,000 by that answer. So second negative pulls up the answer, and there's how much he needs to invest. He needs to invest $3,620.10 if he wants 4,000 after 2 years. And then 21 and 22, this is the stats, the years since 1990, number of wolves. And so we're going to put it in our calculator. So we'll put stat, edit, and put it in. Let's see, 0, 2, 5, 7, 10, 13, 100, 300, 500, 900, 1,500, and 3,100. So we'll go back to stat. We're going to go to the right to calc, and we're going to go to the XPreg, number 0 right there, exponential regression. Go all the way through, and so there's our equation. Y equals 138.37 1.28 raised to the x power. And so as you notice, this beginning is quite different from this beginning, and that's okay. Since this is a scatter plot, this is data points, it's trying to find the line of best fit. It's not going to be perfect, but it'll work. 1993, we're going since 1990, so x equals 3, and we'll plug that in. And so 138.37 1.28 raised to the 3rd power gets me 290 wolves, which again doesn't make complete sense to this table because that's less than it was in 1992 when it should be growing, but it's okay. It's a scatter plot. It's not going to be perfect. Number 22, we got this hypothermia illustration right here with what percent of your brain activity is happening when your body is a certain temperature. We'll put it in our calculator. Stat edit, 50, 59, 68, 77, 86, 98.6, 11, 16, 24, 37, 52, and 100. Go back to stat. We'll go to XPreg, which is number 0. Go all the way through. There's our A and our B. So 1.13, 1.05 raised to the x power. And we want to know for 39, so we're just going to plug that into our x. So 1.13 39, and so we expect it to be about 7.58%. All right, and that's it. Hope everybody is ready for this test.